Section 7.5 is on proportions in triangles. So we start with two theorems. The first one's called the triangle proportionality theorem. So it says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So basically what's happening in this problem is if we have parallel lines, then we can say that our corresponding angles are congruent. So these two pairs of angles are congruent. And then we can say that the two triangles, the big triangle and the smaller triangle, are similar to one another. Okay, so we could go through all of those steps and then we could pair up their different sides and say that those sides are in the same proportion, right? So we have like, TR divided by QR equals UR over SR. So we could go through all of that. But not only does it do that, so not only is this divided by this equal to this divided by this, and this divided by this, right? We could actually go a little bit more specific, and we can say that TR, this one, divided by QT ends up being in the same ratio as UR divided by SU. So its pieces are proportional to one another as well. So the converse to this says if we have the TR over QT equals UR over SU, then we're able to say that the triangles, or that these lines here are parallel to one another. So this statement will work with an if and only if in the middle because the converse is also true. Now the only thing that students tend to mess up on with these types of questions is a lot of times they'll say something like, maybe they'll see that they have 5 and they have 7, and then they have 2 and they have 3 here. A lot of times people will say 2 divided by 3 equals 5 divided by 7, and that is not true. Okay, so really, if I was going to do the 2 divided by 3, then I would need to do the 5 divided by the whole thing, which is 12, because that goes back to the similar triangles. So do you see how this is kind of like the base of this small triangle, and this one is the base of the big triangle, so you need to go back to the big and the small. The only reason the proportional sides works the way it does is because of that theorem where we had like 1 over 2 is the same as 1 plus 2 over, gosh, what is it? What am I trying to say? Equals 3 over 6 is the same as 1 plus 2 over 2 equals 3 plus 6 over 6. Okay, so it's kind of the opposite. It's saying if I started with the two pieces and I subtracted 2 and subtracted 6, it would be the same. So we're talking about these smaller little, this is a small thing, it's not the whole side of the triangle. So I don't know if that makes much sense right now, but you can ask questions about it in class. So let's go ahead and do some examples. So if I have BD is equal to 2 and DC is equal to 2.5 and EC is 4, it says what is AE? So that's going to be like our X here. So this is the triangle proportionality theorem. So it's saying the piece divided by the piece equals piece divided by the piece. And we're able to do this because of these parallel lines right here. So we can say 2.5 divided by 2 equals 4 divided by X. And then we can cross multiply. So we say 2.5x equals 8. And then we can divide 8 by 2.5. So when we do, we get 3.2. So x is going to be 3.2 then. So this is different than what we did last time in class, which is using the whole triangle. So let me show you how it would be different. So if I used the small triangle and the big triangle, the small triangle has 2.5. The big triangle would have 4.5 for its left-hand side. The small triangle has 4, and the big triangle would have 4 plus x. And if you did it this way, it's fine. Like you can say 2.5 divided by 4.5 equals 4 divided by 4 plus x. And then you can cross multiply. So you can have 2.5 times 4 plus x equals 4 times 4.5, which is 18. And you should get the same thing. So you end up getting 2.5 times 4, so 10 plus 2.5, or 2.5x equals 18. Subtract the 10 over, and you're back to that 2.5 equals, or 2.5x equals 8, which gives you x equals 3.2 again. So if you notice, this makes it a lot simpler. So we like that triangle proportionality theorem because it really simplifies those steps for us. All right, so in the figure on the right, it says AB is equal to 25, BC is 10, ED is 8, and AE is 20. It says determine whether or not EB, so we want to see if this is parallel to CD. So we're not sure if those are parallel or not. So if they're going to be parallel, then we're using that converse of the triangle proportionality theorem. So we're going to say if those sides are split so that they're proportional. So if 25 over 10 is equal to 20 over 8, then that means we would have parallel lines. So let's check. So 25 divided by 10 ends up being 2.5, and 20 divided by 8 is also 2.5. So yes, EB must be parallel to DC because these sides that have been split are proportional to one another. All right, so the next one we sometimes call the Side-Splitter Theorem. And I think your online homework, not Side-Splitter, nice, Side-Splitter Theorem. So I think your homework refers to it as this. So if you see that, know what this is. So it says if three parallel lines intersect two transversals, then they divide the transversals proportionally. So you could actually have more than three parallel lines on this, but I'm going to simplify it by calling this A, B, C, and D for these lengths. And basically, if you extend these lines here, these like transversals, you get a bunch of triangles. So you get a triangle here, you have a triangle here, and you have a triangle here. So it's kind of like an extension of that last theorem that we just learned. So it works out that this A divided by B ends up being C divided by D. Okay, so it works that way. And then as you know, we can read proportions in different ways. We talked about that yesterday. Remember when we had like 1/2 equals 3 over 6? We said, oh, well, we can also read it as 1 divided by 3 equals 2 divided by 6, right? Or we could read it as 6 over 3 equals 2 over 1. There's lots of different ways that we can read it. So the same thing applies here. You don't have to say A over B equals C over D. You could say like A over C equals B over D. That would work as well. So A over C equals B over D. So just make sure you're matching up those sides. And then another theorem that we use a lot deals with angle bisectors. Can't remember what this is called, what the formal name is, but something with angle bisectors. Maybe angle bisector proportions. We'll call it that. So it says if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Okay, so again, I'm gonna write some A, B, C's, and D's here. So A, B, C, and D. So I kind of wrote it in a different order here. So this one divided by this one, D over A, is equal to this one divided by this one, C over B. So it's the two sides, like the two pieces that are like on the left and on the right when we have that angle bisector. In this case, on the top and the bottom. And just make sure if you do like the side here for D, then you do the side here on the other one. So you have like the sides divided by the parts broken by the angle bisectors. And again, you can read those proportions in different ways as well. Okay, so here's an example of one. So it says an artist uses perspective in order to draw a row of parallel trees. She checks the drawing by measuring the distances between the trees. She finds that AB is 2.4, BC is 1.4, CD is 2.2, and KL is 2.2. So what are LN, LM, and MN to the nearest tenth? Okay, so if I'm trying to use these two measurements, then I need these two to match up with it. So I'm going to say 2.4 over 1.4 is equal to 2.2 over the length of LM. And we can cross multiply, so I can do that 1.4 multiplied by 2.2. So I get 3.08, and then I divide by that 2.4. So I get, let me write out my steps. It's an LM equals 3.08. So I get LM is equal to 1.283 repeating. So it might be best to write it as a fraction, which is 77 over 60, a lovely number. All right, then we go through the same process for these. So let's say I want to get MN. Well, I don't have to use 1.4, 2.2, LM, and MN. A lot of times I don't want to use a value that I found already. So I'm going to try to avoid using that 77 over 60, because what if I messed it up, right? So what I'm going to do instead is I'm going to go all the way back to the 2.4 right here. So I'm going to say 2.4 divided by 2.2, so this one, equals 2.2 divided by mn. And I do the same process. So I'm going to do 2.2 squared, and then divide by that 2.4. So 2.2 times 2.2, and then divide by 2.4. So I get mn is equal to 2.016 repeating. Or if you write it as a fraction, 121 over 60. So I did math 1 on my calculator. All right, so then it says, what are Ln, Lm, and Mn? So the last thing we need is this Ln. Well, Ln ends up being Lm added to Mn by the segment addition postulate. So we just take our 77 over 60, and we add it to the 121 over 60. So we get 198 over 60, which works out to be 3.3, or as a fraction you could write 33 tenths. Okay, so we have all the different things there. All right, so the next one, it says in the diagram, angle CAD, so CAD, this angle right here, is congruent to angle DAB. Okay, so we know we have an angle bisector again. So this theorem that we just did is going to work. So our theorem says that 9 divided by BD equals 15 divided by CD. So we're kind of stuck because it looks like we don't have enough information. We have two unknowns. We don't know DB and we don't know CD. But we at least have this 14 here, which is the whole length of BC. So let either one be x. It doesn't matter. So since it's saying find the length of DC, let's make that the x. And then the other one is going to be the rest of that segment. It's going to be 14 minus x, right? So if it was like 6, the rest would be 8, right? Or if it was 3, the rest would be 10, or 11. And I can do math. All right, so we're going to set it up, and we're going to say that 9 over 14 minus x is equal to 15 over x, like that. And then we're able to cross multiply. So I have 9x equals 15 multiplied by the quantity of 14 minus x. And I distribute. I do my 15 times my 14, which is 210. I add my 15x over, so I get 24x equals 210. So I take that 210 and I divide by 24. So I get x is equal to 8.75. So that one came out pretty nice, but again, if you want the decimal, just do math 1 on your calculator and you could get 35 over 4 as well. So be careful, like when you use Math Excel, sometimes it will say, write it as a simplified fraction, write it as a decimal rounded to 2 decimal places, so kind of pay attention to those. All right, number 3, so it says in the figure AD bisects BAC. So we have this angle was bisected, so we have those two congruent angles. BC is 7, AB is 4.5, and AC is 7.5. So this is like the last one. We're asked to find the length of DC, so let's go ahead and make that our x. If I didn't specify, if I needed both CD and BD, it doesn't matter which one's x. So this other part is 7 minus x. That looks like a plus there. Let me move it around. 7 minus x. So when we set it up, we have 4.5 over 7 minus x. So the two that are on the top of the angle bisector. And then we have the two that are on the bottom of the angle bisector. So we're going to say equals 7.5 over x. And again, we cross multiply. So I went ahead and distributed already. And then get everything on one side. So I'm going to add it over and I get 12x equals 52.5. So I take that 52.5 and divide by 12. So we get x equals 4.375. So hopefully this kind of makes sense to you guys. You get it? So it says in the figure SV bisects RST. So again, angle bisector. ST is x minus 5. TV is 7.5. VR is 12.5. And RS is x plus 5. So find SR and ST. Okay, so I guess maybe here I should have said DC equals 4.375. All right, so going back here, we're going to have x plus 5 over 12.5 equals x minus 5 times 7.5. So we cross multiply. So I have 7.5 times the quantity of x plus 5 equals 12.5 times x minus 5. And I distribute 7.5 times 5, so 37.5 equals 12.5x minus 62.5. And I get everything on one side, so if I subtract that 7.5 over, I get just plain 5x. And if I add the 62.5 to 37.5, I get 100. So 100 equals 5 times a number, so our number is 20 then. So in this case, we have to go back and plug in, because SR is x plus 5, so it's going to be 20 plus 5, or 25. And ST is x minus 5, so it's 20 minus 5, so it's 15. So we need to find both of those.